Okay, so just remember a type 1 error is the null is true, but we're rejecting it. Basically, we're getting rid of the null, but it's actually true. So we're getting rid of the null. In this case, we're saying, okay, get rid of the null. The person, so we're saying that the person is guilty when in fact they are innocent. Okay, they're convicting an innocent person. That's the consequence of the error. So just take a look at two things here. This is the consequence of the error. They're convicting an innocent person. But if we said what is the type 1 error in context, that would be stating that the person is innocent, but the jury finds them guilty. That's the statement, and then the I just lost my thought. The the consequence is the jury could convict an innocent person. Okay, so what is a type 2 error? So remember, a type 2 error is FF, failing to reject the null when it's false. So that's basically like saying keeping the null. So we're keeping the null, but it's not true, okay? We're assuming that the person is innocent, but in fact they are not innocent. So we think they're innocent and they're not. They're actually guilty. So what is the consequence of that? The consequence is that they let a guilty person go free. They failed to reject the null when it's false. They failed to reject the fact that they were innocent when in fact they were actually guilty. Okay, so the judicial system is set up to make type 1 errors less common. Okay, so they don't want to convict an innocent person. They don't want to have a type 1 error by requiring strong evidence for conviction. So when you think about this and you think of the consequences, you always want to think of what is worse, a type 1 or a type 2 error. Okay, so let's just take a look at a couple of different situations. So here's the first one. Maybe you've seen the new movie about O.J. Simpson. So just remember, in our jury system, you're innocent until proven guilty. So this is how we would set up a hypothesis statement. One, what is the probability that O.J. is innocent? So we're assuming that O.J. is innocent. The alternative is that he's not innocent. Now note here that this is a two-tailed test. Okay. The lawyers give evidence to prove their case. The jury comes back with a verdict. They did not say OJ is innocent. So they didn't say, hey, he is innocent. We have full evidence to say that he's innocent. They said not guilty. So, okay, but keep that in mind. We all knew OJ was guilty. The jury says not guilty, but that's not saying that he's innocent. That's just saying they don't have enough evidence to prove that he is guilty. Okay, so they didn't have enough evidence to convict OJ. So we never accept the null hypothesis, right? So just remember, this is another reason why we never accept the null hypothesis, because we have a chance of making a mistake. Basically, it's like saying this is why we state we don't have enough evidence or we fail to reject. All right, that's why we say we never accept it, because we're never 100% sure. We're just not saying we don't have enough evidence to reject it. Now, if the jury had enough evidence beyond reasonable doubt, they will say guilty. All right, we do the same. If we have enough evidence, we sort of saying like, hey, this person or this null is guilty, so we're rejecting it, and the null hypothesis is essentially guilty. All right, so let's look at the same sort of table when we're talking about O.J. Simpson. So the null, not guilty. Alternative, he is guilty. So if he's not guilty and he is convicted, the null is true, but we rejected it, and innocent OJ gets convicted. That's a type 1 error. That's the little alpha there is that we'll go over what that means. If the null is true and he's not guilty and we fail to reject it, he's not convicted. That's a correct conclusion, and an innocent OJ is not convicted. What if our null is false and we reject it? Hey, that's good. He was guilty. He was convicted. He goes to jail. Type 2 error, notice that's called beta. We'll go over that. Is called a false negative. So double false. The null is false, but we fail to reject it. So when the null is false, we fail to reject it. We keep the null, but it's not actually true. So that's like saying, hey, we think that a guilty OJ was actually not convicted. Okay, the null is false. He's actually guilty, but we failed to reject it. We didn't convict him, so he did not go to jail. Okay. Let's continue taking a look at the case of OJ. So what type of error was made in this case? In this case, a type 2 error was made. We failed to reject the null, so we said, hey, he is innocent, when in fact he probably was actually guilty. So that was a type 2 error. Now, what are some consequences of that error? So two things you want to be able to do: identify the error and then also identify the consequence, okay? So the consequence of that error is that a guilty OJ is not convicted, so he committed a crime and doesn't actually go to jail. All right, so I want you to try this one, sort of think about this one before I go over the answers. Let's say that the null, we're going to think about a smoke alarm going off. Let's say the null is that there is no fire. The alternative is that there is a fire. Okay, now what does a type 1 error look like? Remember, a type 1 error is that the null is true, so there is no fire, but we are rejecting it, so we're getting rid of it. There is actually no fire, but we think there's a fire. So a type 1 error is if the alarm goes off, you run out of the house but found out there is no fire. So we said, oh, the null was true, there is no fire, but we rejected it and said there is a fire, so we run out of the house. Nothing really happens here. Okay, we're good to go. We go back in. Okay, it's like fire alarms at school. Okay, a type 2 error, remember, failing to reject the null when it's false. Okay, so we're keeping the null. So basically we're saying there is no fire when in fact there is a fire. So the alarm goes off, you ignore the smoke alarm, and found out that there indeed was a fire. Which of these two is worse? Okay, the worst one would, in this case, would be type 2, because the consequences are that you may burn in the building that you're actually in. All right, so let's take a look at this one that deals with potato chips. So a potato chip manufacturer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment and then perform a significance test using the following hypothesis. Okay, the null is in fact that 8% of the potatoes in the shipment have blemishes, and the alternative is, hey, we think they're trying to get away with something. There is in fact more than 8% of the potato chips that actually have blemishes. Notice how P is defined. P is the actual proportion of potatoes with blemishes in any given truckload. What I want you to do is describe a type 1 and type 2 error and explain the consequences of each. And when it says describe a type 1 and type 2 error, that doesn't just mean like, oh, a type 1 error, the null is true, but we reject it. Type 2 error is the null is false, but we fail to reject it. What is it in context? And let's see what that looks like. All right, so a type 1 error is, remember, we're getting rid of the null. But it's actually true. So we get rid of the null, so we say, oh, it had more than 8% of blemishes, we're getting rid of that truckload. So basically we're rejecting a good batch of chips. So what is the consequence in that? The potato chip producer sends a truckload of acceptable potatoes away and they could lose revenue. Okay, that's the consequence. Make sure you include that. Type 2 error is failing to reject a bad batch of chips. So that's basically like saying the null is false, but we fail to reject it. So we say, ooh, hey, this looks like it only has 8% of blemishes when in fact it has more than 8% of blemishes. So the producer uses the truckload of potatoes to make potato chips, and more chips will have blemished potatoes, which could potentially result in upset customers. All right, and this is what it would look like if you decided to make a table out of it. Okay, and if that's easier for you to do, go for it. All right, now what is the probability that we make a type 1 error? Remember, a type 1 error occurs if we reject the null when it is in fact true. Okay, so we're rejecting the null when we should not have. When do we reject the null hypothesis? Let's think about this. We reject the null hypothesis if our statistic is less than our alpha region. So we reject it when the probability of the statistic falls in the rejection region is in the shaded area or our alpha region. When it sort of, remember when I was sort of shading it in, it doesn't span the reject and fail to reject it, it just gets into the rejected section. Okay, so let's consider a test where alpha equals 0.05% right here. This means we're rejecting the null 5% of the time and failing to reject it 95% of the time. Since a type 1 error is when we reject the null, Okay, so right here we're rejecting the null 5% of the time. A type 1 error has the same probability as the alpha. Because think about your alpha. Your alpha is 5% of the curve. I'm rejecting it 5% of the time. A type 1 error occurs when we reject the null. What percent of the time are we going to reject the null? Well, we're going to reject the null alpha percent, so therefore a type 1 error is the same as alpha. Okay? All right, therefore the probability of a type 1 error is equal to the significance level, or alpha. The probability that the test will reject the null when it is in fact true is alpha. So what can we do to reduce the probability of a type 1 error? Are there any drawbacks? If we want to reduce the probability of a type 1 error, we decrease the significance level. So we go from 10% or 5% or 5% to 1%. Therefore, we will not be rejecting the null as often, so we're going to only reject it maybe 1% of the time. However, keep in mind that if we're only rejecting it 1% of the time, we need even more evidence to reject the null than we maybe necessarily need to. Okay, so now the probability of a type 1 error is the probability of rejecting the null when it's really true. This is exactly the same as the significance level of a test. So the significance level and the type 1 error are related because they're pretty much exactly the same thing. Alpha is the probability that the test will reject the null, okay, and it's also the same as the type 1 error, which is rejecting the null when the null is actually true. Now, before you decide what a significance level to pick, you want to consider the consequences of a type 1 error before you choose a significance level. So if the type 1 error is really, really bad, like you're staying in a burning building with a fire, then you would want to have a really low significance level, like 0.01, to make sure you only reject the null when you need to. So you have a low level of significance, so you're not rejecting the null very often. Therefore, you're not having a type 1 error very often. Okay, so let's take a look at our truckload with potatoes problem. So here are our null alternative, okay, where P is the actual proportion of potatoes with blemishes, okay, still defined. Suppose that the potato chip producer carries this test based on a random sample of 500 potatoes using a 5% significance level. Ooh, okay, so now we're doing a sampling distribution of P hat. Okay, notice 95% of the time we're failing to reject it, 5% of the time we're rejecting it. That is our alpha level or our significance level, which is the same as the probability of a type 1 error. Now, the shaded area in the right tail is 5%. Sample proportions to the right of the green line over here, okay, will cause us to reject the null even when it's true. So basically it's like saying this is going to happen in 5% of all possible samples. So since I'm rejecting it 5% of the time in 5% of all possible samples, okay, then I have a probability of making a type 1 error. All right, now type 2 errors are a little bit trickier with their probabilities. A type 2 error occurs if we fail to reject the null when it's false. So basically we're keeping the null even though it's false and we should have gotten rid of it. So when do we fail to reject the null hypothesis? So when do we fail to reject the null? When we assume that the null is true and find that the statistic of interest falls outside the rejection region. Okay, so basically what this is saying is that when do we fail to reject the null? It's basically like saying that we find the statistic of interest and it falls outside the rejection region, or it sort of falls in that fail to rejection region. So if you had the 95 and the 5% of the curve, it would be falling in that 95% of the curve instead of that 5% of the curve. The probability of a type 2 error depends on several factors, including the actual value of a parameter. A high probability of a type 2 error for a specific alternative means that the test is not sensitive enough to detect that the alternative is actually true, okay? So the probability of a type 2 error is denoted as beta. And just we won't have to actually calculate the probability of a type 2 error other than like a simple calculation, but I just want you to understand that a type 2 error is we're failing to reject the null. So it's basically like saying we don't have enough evidence to reject it, but so our test that we did is not sensitive enough. I didn't take a good enough sample or whatever to detect that the alternative is actually true. Okay, you'll never be expected to calculate it other than doing a simple subtraction problem. Okay, and we'll actually go over the power of the test in the last video for this long section.